Hello, in this video we are going to discuss all the important points and formulas of the chapter work energy power, which has a great weightage in the GATE examination. So let's start. At first, work done by a force F is written as F dot D. This is Fd cos theta. Work done to move any particle at distance d is written as Ft cos theta. Note this conversion: 1 joule equals to 1 Newton into 1 meter equals to 1 kg meter square per second square. Also there is, note this conversion: 1 arc equals to 1 dyne into 1 semi equals to 1 gram semi square per second square. Kinetic energy is written as half mv square. Work done can be written as change in kinetic energy, which is also written as half mv1 square minus half mv2 square. If the velocity change from v1 to v2, the work done is written as half mv1 square minus half mv2 square. For variable force, for a force which is variable with respect to dx, for this work done equals to integration of f dx. Also this can be written as ma dx, where f equals to ma. Integrating this, we get m by 2 v square plus u square. Potential energy for any particle can be written as minus of f dx. Please note down work done is f dot d and the potential energy is f dx. Law of conservation of energy. This is very important. If at a time t the kinetic energy is k1 and the potential energy is u1, and at a time t1, at a time t2, if the kinetic energy is k2 and potential energy is u2, then it can be written as the kinetic energy at the time t1 plus kinetic energy, potential energy at the time t1 is equals to kinetic energy at the time t2 and the potential energy at the time t2. Potential energy can be written as mgx or mgh. Mgh is the height where the particle belongs from the ground or from the system of reference. Kinetic energy can be written as mg into h minus x. Here, if the potential energy is mgh, so the kinetic energy is mgh minus mgx. Work done by spring can be written as half kx square. X is the contraction of spring. If the spring is contracted for x times, so the work done by the spring is half kx square. If the spring is contracted from the point x1 to x2, then the work done by the spring is half of kx2 square minus x1 square. Please note down this point. If a body of mass A moving with speed v collides with a spring, the spring gets compressed by x. If the body of mass moving with speed v collides with a spring and the spring gets compressed by the factor x, then maximum contraction on the spring can be written as root over of mv by k. This is very important formula. Maximum contraction in the spring can be written as root over of mv by k. If a body is released from a height h and collides with a spring, If a body is released from a height h and it collides with a spring, then the formula for maximum contraction is root over of 2 mgh by k. This is the formula for maximum contraction if a body is released from a height h and it collides with a spring. Average power can be written as total work done by the total time taken. Average power can be written as total work done by the total time taken. It also can be written as total change in kinetic energy by total change in time. Instantaneous power can be written as P equals to F dot V. V is the velocity, F is the force. Efficiency of an engine or any system can be written as work done by energy input. If we know the energy input and the energy output or work done from the engine, we can easily calculate the efficiency of this engine. So we have discussed all the formulas of work, power and energy, important formulas which is important for NEET. Hope you like this video. Please subscribe the channel.